Great. Thank you very much to Helen for a great recorded talk. She is here online. There are a couple questions in the chat, but maybe before I start with those, Helen, do you want to do a quick microphone check just to make sure we can hear you?
Yes, hi.
Great, hi. So maybe for some context, did you know Chapel before joining this project? Or did you learn Chapel as part of the project?
So I learned Chapel in the internship in the summer before my master degree in the same lab. And then when I began last year, I was already coding with Chapel. Yeah.
And did you have sort of experience in parallel computing before that internship?
So yeah, a bit. I had a project within my bachelor with the C++ and MPI.
Mm-hmm. Okay,
and,
great.
Yeah.
Mm-hmm. Nice. So just sort of as a follow-on question, so Brad Chamberlain had a question, which was his comment and question. It's great to hear about students being able to do things more easily in Chapel. And his question is, if you could magically fix one of your pain points with Chapel, what would it be?
Oh, I would say maybe the compilation time, because while we're programming and we want to test things easily, sometimes it's a bit long to compile each time, and it can be a bit tricky with the time we have. Yeah.
Great. Yeah, that's I think that's a common thing. Well, I think compilation times have improved over time, but that was a common experience I think my students have had as well. Let's see, there's a clarification question on slide 15 of your slides. You have the acronym PRN there. Is that pseudo-random number, or is that something else?
Exactly. Yeah. It's a pseudo-random number. So since like real randomness can't be generated, so we call them pseudo-random because it's a copy of what random would be, but it's not exactly random. So it's the best way we can do random number in our application.
And I assume as part of your validation, since you have this stochastic method, you're doing lots of trials, and the results you show are, I guess, mean values. And is there a lot of variability about those?
So if maybe I can share my slides.
Yeah, please.
Okay, so here on my results on the left, it's in fact 10 different results of the stochastic method that have been overlaid on top of each other. So for the area that are darker, it's where they're more likely to have ice. And for the areas which are lighter, it's where we don't see ice on every run. So it's the stochasticity that appears here. Yeah.
I see. Okay, great. And then maybe just one sort of final quick question. First, good luck on the competition or the workshop that you're going to attend. Do you already know how your results compare to other codes, or would you only know at the workshop?
Yeah, so we know a little because we are part of the committee. We are compiling the result for everyone, so we already see if we are good or not compared to the others. And yeah, we are in the same. We have the same results, and yeah.
Great. Well, thank you again for a great talk.
Thank you.